Okay, today we're talking about more probabilities. So this is called a contingency table. So grab your notes, find this chart, and I will expect you to follow along with me so that you can understand how to use a contingency table. Okay, so if you look at this table, we've got soda here as our first category. And in Minnesota, we would usually refer to that as pop, okay? And they have a total of 38 people that liked soda. Well, if you drill a little deeper here, we've got 10 people in the age ranges, this is age, from 20 to 29, who preferred soda. If you go through that same age range here and look this way, 8 people preferred coffee, 5 preferred tea, 2 preferred water, and if you add all of those up, double checking it, adds up to 25. Yay, yeah, that works. All right, and if you add all of these blue ones up, they add up to 38. So it's about probability, right? And they asked 100 people, which is a really nice round number of people. And they were able to divide them up into these categories. These were the 5 people who were in this age range and liked tea. This 11, that would have been the people who were the total number of people who liked tea. Okay, so that's that 11 right there. So if you were only talking to tea lovers, then you would zoom in on this category right here, and you'd say, what's the probability that we have somebody who's in their 40s and likes tea? All right, well, you follow this over here and say, these are the people that are in their 40s, and there's one person in their 40s who likes tea. Well, if we were only talking to tea lovers, there was 11 possible, and there's only one person in their 40s who likes tea right there. So that would be a 1 out of 11 probability. What if we were actually asking about the whole group, like out of all 100 people? What is the probability if you just grabbed a random person out of those 100 people that they would be this one person? Well, obviously, then that would be 1 out of 100. So how do you decide? Is it 1 out of 11? Or is the answer 1 out of 100? Well, it depends on what the question is. If you're only asking tea drinkers, then that's what's possible is the 11. If you're asking everyone, then there are 100 possible people. And there was only one tea drinker in their 40s out of 100. All right, so there is the most complicated part. It's usually pretty easy to find the numerator, the top part. But whether or not you're going to take it out of 100, or if you're going to take it out of one of these subcategories, like if we only ask tea drinkers, figuring out the denominator is the hard part, in my opinion. Okay, so let's go into the notes a little deeper. So the owners of Tic Tac are going to distribute randomized passwords. They'll be 6 characters long, 4 letters, and 2 digits. All right, so this is a warm-up problem. And do you remember we had 4 letters? We'd put blanks out like this, and then 2 digits for the passwords, as in these are numbers right here. I'll make them a different color blank. Do you remember me talking about multiplying choices? All right, I would like you to try these 2, and we'll have whoever's teaching pause the video for a minute while you try to answer these 2 questions. Take this seriously. This lesson's going to go fairly short. Okay, so the total number of different password combinations that Tic Tac can make. Well, in these black blanks here, excuse me, these were going to be the 4 letters part. All right, well, how many choices do you have for letters? 26 for the first letter, 26 for the second letter, 26 for the third letter, and 26 for the fourth letter. That means that they could have all the same letter. if you wanted. Like if you got an L this time and then you got an L this time, that'd be okay. You could also have a different letter here and a different letter here. All right, so if you had to have a different letter every time, if you had to have a different letter, this would have been a 25, this would have been a 24, and this would have been a 23. That's because you wouldn't have as many choices. Because if L already got picked at the beginning and you weren't allowed to have a repeat, well then we would have had to change this to a 25 choices. All right. But they didn't say anything about that. I'm just reminding you because I know we do that sometimes. Now it's a 2-digit number. Well, remember there's 0 through 9 for a single digit. So that is 10 choices. And then there's 10 choices for the last number. So that's a reminder of how to do that kind of question. All right. You'd actually multiply these all out to get your final answer. Let's look at B. If the first 2 letters have to be T, well then how many choices do you have? Remember, it's all about multiplying choices. If it has to be a T, you only have one choice. It has to be a T. So does this. But then the next 2 letters apparently can be anything. So 26 and 26. Then the numbers, they didn't say anything about that, so they didn't limit that at all. So we're going to say times 10. And the last blank is also a number, and there's 10 different things when you count 0 through 9. And so there, much smaller number of choices. Why? Because you didn't have as many choices here. You had to pick the letter T for those first 2 spots. Okay, so I want to also just briefly remind you, I'm not going to do this whole problem, but that you need to know how to do the kind where you have a big thing on the outside, like a pool, okay? Or a roof in this case. The roof is 25 by 30, so let's make this 30, let's make this 25. This is not to scale. And there's a circular pool with a diameter of 12 feet, so that's like this with a diameter of 12. Remember, that's not the radius. And to do this type of a question, you would figure out what you want, which is probably going to be that you land in the pool. So what's the probability of hitting that out of the whole thing? So you would take your probability, which is what you want, out of what's possible. What you want is that circle there. Well, the radius is 6, so you go pi times r squared, which is the radius, which is 6 squared, over what's possible is this big one, which is the 30 times the 25. You definitely have a calculator for this, so you'd use 3.14 for pi, and you would just divide them. All right, what's probability you will not land in the pool? I tried to teach you that not means you take 1 minus whatever that was. Okay, now let's get into this new stuff. So they're basically sorting the data into categories. They've taken 100 people here, and they said, hey, who likes snowboarding? Okay, who likes skiing? Well, these are the people who are 35 and under. Notice there's 43 total of them. And there's a fair amount of snowboarders in that younger group. In the older group, it's more skiers. Here's the older group. So, make a statement you can support with the data above. Well, you could say that more than half of the total people liked snowboarding, because I'm looking at these numbers right here, and that's 55 out of 100, which would be more than half of the total people like to snowboard. All right. So this is data that has had a line drawn through it to kind of predict it. And it's saying basically the higher your temperature goes, as it gets up into the high hundreds, the lower your number of people will be at the fair. Because basically it's getting so hot that maybe only 4,000 or 5,000 or 6,000 people would want to be there anymore. Whereas if it was nice, cool 60 degrees, then maybe as many as 10,000-ish people would like to be at the fair. This is definitely not the Minnesota State Fair. We have way more people than that. But all right. So I think I'm going to just move on. I want to keep this video shorter. This is a contingency table. We talked about this one before. If you were to answer these questions about this table, I'd like whoever's in charge of the video right now to pause it so that you can take a minute and try to answer these questions. Let's say if you had about 3 minutes, maybe 5, well, that would be enough. And then I'll talk through those answers. All right, let's see how you did. How many people were polled? Well, that is your total number of people. So you should have said 100. How many were 30 to 39 years old? Were we just talking about soda? No. 30 to 39-year-olds. Of these numbers, which one of them represents how many people were between 30 and 39? What's that last one? You should have said 25. How many preferred coffee? Well, you know, they weren't clear if they were still talking about the 30 to 39-year-olds or just generally. But since the question doesn't have anything about 30 to 39-year-olds in it, I'm going to assume that they mean how many people total preferred coffee. So I'm going to go to the coffee column here, and I'm going to pick out that bottom number and say 34 people preferred coffee. Now, if they'd asked me for the probability that I'd get somebody who preferred coffee, probability is what you want out of what's possible. That's would be the probability of getting a person who liked coffee. All right, and how many were 20 to 29 and preferred water? All right, 20 to 29 is the top column there, or the top row, I should say. So I'm going to highlight that. And what did they say about them? Oh, preferred water. So that's this one right there. So that's, you had to be both 20 to 29 and you had to like water. So that's a very small group of people. It was 2. Okay, so that's just getting data off of these tables. And now they're going to actually ask us some probability questions. Same table. What's the probability that a person polled was 50 to 59? All right, whoever's in charge of the video, this is a good time to pause for a minute. Have kids try these 3 questions. And kids, we're almost done here. Give me your best for just a couple more minutes trying these out, and then we'll have some time to work on homework. So I'll have you pause for just a minute to try these. Okay, we're back. What's the probability that a person polled was 50 to 59? Well, first I'm going to go find the 50 to 59-year-old area. It's all of this. If you want all of the people, no matter whether they like soda or coffee or tea or water, it's 25 people. So what's the probability that a person polled? That means like out of everybody they talked to, what's the probability that you got a 50s-year-old person, somebody in their 50s? Then it's what you want is these 25 right here. Out of what's possible would be there was 100 people you could have polled. This reduces, of course, to 1/4 or 0.25. What's the probability that the person polled preferred tea? All right, well, this implies that we're still talking about the 50 to 59-year-old. Okay. Now, it's really hard to know if that's what they meant or not. But is the 50 to 59-year-old in the question? I don't see it in there. So that means we're just talking about tea lovers, which is all of the tea lovers, not necessarily the 50-year-old ones. So I'm going to interpret that as meaning 11 tea lovers out of 100. And I totally get why you might have thought they were talking about 50-year-old tea lovers, which would have been 3 out of 100. But it didn't say that, did it? All right, here's an and. You have to be both. Like if they ask you, are you between 40 and 49? And you say yes, then you also have to say yes to, do you prefer coffee? All right, so this is a very small group. And ones are small groups because you had to have to do this and you have to do that. It's like if I had the kids in the class right now raise their hand if they had a piano, and then I said, oh wait, and you have to have a cat. Well, that's going to make it a smaller group. So ands are small groups. All right, so 40 to 49, Ann prefers coffee. All right, here's 40 to 49. I'm going to highlight that row. Ann prefers coffee. That's those. So it's a small group, right? It's not the 25, it's the 9. All right, so it's 9 people, but that's not a probability. 9 is what I wanted out of the total of 100. I told you before that if they had said, we're only going to talk to people who like coffee, well, then it would have been out of 34. But it didn't say that we're only talking to people who like coffee. All right, so unless it narrows it down like that, we take it out of the grand total, which was 100. So 9 out of 100. All right, let's go to this page. The probability someone polled given a certain characteristic. Given. Now, whenever you see the word given, that means that you have a different denominator. You can bet it's not going to be out of 115, which is the biggest number there. It's going to be out of something else. Given a person prefers cookies, do you get, we aren't going to even ask the other people. We're only going to ask the people who like cookies. So it's got to be this group, which means it's not out of 115, it's out of 30. Remember, because it's what you want out of what's possible. The possible people we asked was 30. I'm going to abbreviate this, POS. All right, so those are the possible people was 30 because we're only talking to cookie lovers. Now, they prefer Mario Kart. All right, so of these people, which were the Mario Kart people? Right there. So it's 4 out of 30. Remember, if they hadn't said that given thing, it would have been 4 out of 115. But they said we were only talking to people who liked cookies. So it was 4 out of 30. Given you're talking to a person who prefers Candyland, what's the probability that they like pizza rolls? All right, given the Candyland, then given means I only am going to talk to these people. That is a given. I'm only talking to those 25 people, so it's out of 25. Preferred pizza rolls, I'm only looking in this side of this circle. Pizza rolls, 10. Do you get if we thought, oh, I think the pizza rolls number is 44. 44 out of 25 wouldn't make any sense. So it was 10 out of 25. And yes, you should always reduce those. I like to do it this way. This is 5 times 2, and this one's 5 times 5. And if you can factor it, you should. Then those cancel, and I get 2/5, aka 4/10, which is 0.4. All right, so this is just a slide that's ranting about the given. Whenever you see given, it changes the denominator, changes what it's out of, because this is called conditional probability, and there's a condition now that you're only going to talk to people who like snowboarding or something like that, and it'll change what is possible. So try to remember that whenever there's a given, it changes the possible to be something new, and it's usually I think it's always a smaller amount than if you had asked everybody. All right, and there is this fancy pants symbol right here. It's saying given that, or under the conditions that A. Let's say A is that you saw an aardvark. Well, then they're only talking to, given, they're only talking to people who saw an aardvark. And B might be that you like bananas. So it'd be probability that you like bananas given that you saw an aardvark today. And then you go look it up on your chart. So the given, weirdly, is the second part. Okay, given that this condition was true. All right, so we are not doing a worksheet. I have found a awesome Schoology quiz for you. I cut it down to just 10 questions. And I'm absent today, and I have to have a procedure done tomorrow. I really appreciate it if you guys would take this seriously. Open up that Schoology quiz right now. You realize how terrible it would look if you don't even open the Schoology quiz, because I can see. I'll look tomorrow night, and I'll see who has gotten in and started their homework. I don't expect you to have it all done by the end of the hour, but if you haven't even started it, we're going to have a conversation about your attentiveness. All right, so give this assignment a shot. It's a 10-question Schoology quiz that you'll find in today's folder. And that's all I got for you for today.